Gonna give B is intermediate, right? And then C after that, which is also intermediate, and then you're gonna have the product D. So the reactant A finally gives product D, but you have B and C intermediate. Okay, so you have the multi-step reaction. So in this reaction, you have the energy, activation energy, EA, that is given, right? So from A to B, this is the EA you have, right? No, this is the EA, 15 kcal, and then the delta H, enthalpy change for that is plus 13. That's the endothermic process, okay? And then you're gonna have B to C, so intermediate to intermediate, you're gonna have the minus 6, which is exothermic reaction, right? And then C to D, you have the final product with this energy, so also exothermic reaction, okay? So now let's see the question, what it is asking. So what is the enthalpy difference between A and C? So you don't have A and C over there, right? So you're gonna solve and then you're gonna calculate, okay? So let me draw first. So you're gonna make more sense. Otherwise it's gonna be a little bit confusing, right? So this is the overall. If you plot all energy in the same graph, so what it's gonna look like? So you're gonna start from A, right? So I'm gonna start somewhere over here because you're gonna go to negative value. So let's say this is gonna be A, for example. Right? So now first you're gonna go A to B. So see the value of B. So plus means you're gonna have B somewhere over here above A, because it is plus. So B should be higher than A. Okay? So I can write B over here. And then from B to C, you have negative 6, right? So if you have C over here, going to be equal to B. You have negative, so you're going to go a little bit down, but don't go too far down. You cannot go below A, right? So you have the difference between these, A and B. So that difference is going to be, what is going to be the value of that difference over here? So this difference is going to be, let me draw A over here. Okay, so this is A. So that's going to be, what is the difference for that? 13, right? So this is 13, difference you have there. So B is 13 above A, right? And then now, you're going to go from B to C, so I'm going to go about halfway. It is minus 6 from B to C. So I'm going to make halfway over here between A and B. So that's going to be C. Right? Get it? So if I put C over here, going to be same as B. So you're going to go minus 6 from there down. So a little bit below B. Okay? And then C to D, so now you're going to have more negative. So that's going to make below A. So when you go 6 down from here, 7. So this is going to be equal to A. And then you're going to go 13 below that. Right? So I'm going to make somewhere over here. That's the D. So you're going to have A to B. And then you're going to have B to C. And then you're going to have C to D, something like that. Right? That's the profile. Okay, so now what is asking? A and C. So you're going to find the difference between A and C. So A going to be this one, right? C going to be this one. So that difference is asking over here. So now you're going to solve that, right? So how are you going to calculate that? So this is 15, right? And then 15 minus 6 is this one. So now what is going to be C to A? Positive 7, right? So C is above A. You're going to have the plus 7 kilocalorie per mole. Right? So what is the answer? A, B, C, D? A, right? That's the answer. Okay, this is our track. So above and below. So value going to be the given the difference, or you may have to add sometimes, right? So good. This is not hard, right? Okay. Number 10. So you have the reaction of chlorine with alkane. So this is halogenation, right? So the steps are given over here, which would be chain termination step. So now this will be easier, right? So you have 3 steps over there. You will have the initiation step. If you have the molecule on the left and radical on the right, you're going to have the termination opposite to that. You're going to have the radical on the left and then the molecule on the right. So you're going to do that. So this one you have radical on both sides, so this is not the option to choose. And then you have radical both over here, so this is not. So these two are propagation, right? And also here you're going to have on both sides, so this is also propagation, right? So this is propagation, this is propagation, so let me see the other one. So you have the molecule on the left and then radical on the right. So this is going to be initiation, right? So now what is happening? So you have that. So you have radical on the left, molecule on the right. So this is going to be the termination. So you're going to choose 3, right? So we're going to do that. Good? Okay. And then now you have the radicals again. So you have 3 given. 1, 2, 3 labeled to that. You're going to order them with decrease in stability. So you're going to put the one that is most stable first, and then you're going to go all the way to the last that is least stable. Okay? So now, do you know one trend you have? 3 degree gonna be more stable than 2 degree, then 1 degree, then metal, right? So that's the trend we're gonna follow. Okay? So the more alkyl group you have on the carbon that has the unpaired electron, which is radical, that's gonna be the most stable, because the methyl group is gonna provide the electron for that electron deficient center to give more stability. That's the reason why 3 degree is the most stable you have, right? So now you're going to see over here. So if I draw 1, I can draw this way. So you have the carbon radical, and then I have CS3, 2 of them. I can draw like that. And then I have the ethyl over there. Let me write C2 as 5 together. So that's the bond you have there, right? So how many CC bonds you have for the carbon that I did dot over there? 3. So this is 3 degree, right? And then let's say number 2. So for 2, I can draw the same way. I'm going to focus on the carbon that I did dot in it. And then you have all R, let me write R for the whole thingy over there. So R, this is general notation, right? So I have R over there, which is 1 CC bond, right? And then I have 2 hydrogen in it. So I have that. So how many carbon-carbon linkages you have for this carbon? Only one. So this is 1 degree, right? And then the third one, I can do the same thing. So you start from the carbon, the dot. I have 1 CH3, and then I have the 1 hydrogen there, and then I have CH, and then you have the other one, right? CH3, 2. So this CH3, 2 going to be on this carbon, not on the radical carbon. Don't be confused with that. Okay? So now how many CC bond you have for this? 2. So you're gonna be 2 degree. So now you're gonna arrange. So write 3 degree first, 2 degree after that, 1 degree after that. Right? So you're gonna do 1 structure, that's the highest, and then you're gonna do 3 after that, that's gonna be the second highest, and then you're gonna have 2 at the end. So let's see, which option you have this trend? A, right? So this is same as this one. So you're gonna choose this. Good? Alright. So number 12. So you have the monobromination, that means only 1 bromine addition. Okay, so mono means that. Mono is 1, di gonna be 2, tri 3, tetra 4, like that, right? So you have the monobromination, they say put only 1 bromine, not more than that. Okay? So you're gonna make the product from here. Again, you're gonna keep the same concept, the previous one, degree of carbon. So you're gonna have the radical first in the mechanism, and then you're gonna add the bromine into that radical. Okay? So when you have the product, if possible, you're gonna choose the 3 degree carbon for the substitution. If it is not, go to the 2nd degree carbon after that. If not, you're gonna go to the 1 degree carbon. That's the hierarchy you're gonna go. Okay? So let me draw the same molecule in the easy being conditions. You're gonna have 3 CH3. So you have 1 carbon, and then you're gonna have 3 CH3 on that. Okay? And then I'm gonna go to next carbon, which has 2 hydrogen there. I'm gonna put hydrogen over here like that. And then after that, I'm gonna have CH3. So that's the bonding you have in this molecule. So they're gonna be easier to see the degree of carbon you have. Okay? So now, do you have any 1 degree carbon there? Do you have any 1 degree carbon? Okay, so this gonna be 1 degree, this gonna be 1 degree, this gonna be 1 degree, right? And then you're gonna have CH3, this gonna be 1 degree, right? So we have more than that. We have 2 degree carbon. So you have 2 degree carbon, right? So you have 1, 2. So this gonna be 2 degree carbon you have. Do you have any other 2 degree carbon? No, right? Do you have 3 degree carbon? So which is 3 degree? This carbon? 1, 2, 3, 4. It is 4 degree carbon, not 3 degree. You have only 3 cc, right? You have 4 cc over there. So that means it is not possible to have the radical on 4 degree carbon. You don't have hydrogen there. It's not easy to break CC bond. It is easy to break CH bond to to have the radical, so it doesn't prefer. Okay, the other way is, for the chlorination or bromination, you're going to replace the hydrogen by halogen. You never replace carbon with the halogenation. Okay, always the hydrogen. So you're going to pick the carbon that has the hydrogen in it. So the 4-degree carbon doesn't have hydrogen. So you should not pick that. Okay? So now, after that, what is the possibility? You have green, which is 2 degree, right? So you're going to have the 2 degree. So either you're going to choose this carbon, or you can choose any of the 1 degree carbon. Why you have only 2 choices? These are the only carbon you have the hydrogen attached to. You don't have any other carbon that has hydrogen, right? So now, which one do you choose? 1 degree or 2 degree?
2 degree.
2 degree. So see something product that you have the bromine in place of this hydrogen over here. That's going to be the product. Okay? So now, which is the option you have? So that's the bromine you have on this carbon, right? So you're going to choose that. So B also has bromine, but you cannot have 2 hydrogen and then R the bromine there. That carbon going to have 5 bonds. It's not possible, right? And then this one. So you don't have 4 groups over there, right? So it's not possible. You don't have 5 of Cl3 there. And then CH3, you have 3, not 2, right? So be careful with the small substituent over there. So you're going to choose which one? A, right? So you don't have any change if you compare with the reactant. Only change is you're going to replace 1 hydrogen by bromine. That's the change you're going to have. Right? Good. Are you confused? No, right?
No.
Okay. So choose the highest degree carbon. Doesn't mean that you're going to choose 4 degree. 4 degree doesn't have the hydrogen in it. Don't choose that. So if possible, choose 3 degree carbon. It's going to have 1 hydrogen attached to that. If not, you're going to go to 2 degree. It's going to have 2 hydrogens attached to that. So it is a monobromination. Don't replace both hydrogen. Replace only 1 hydrogen. Okay? So that's how I would do it. 13. Which of the following does not represent the structure of conditioned state? You have the reaction HA and B minus. So this is with the 2 electron in it. And then HF, HB, and then you have A minus, right? So, which is going to be the answer? You have A, you have B, you have C, you have D. So remember, the transition state is the intermediate. You have the both process, bond breaking and bond making, happens at the same time. So both the reactant and the product gonna be partially bonded together. So as the intermediate, right? So here, what do you need to do to have the product? So in product you have A separate, so you're gonna break that bond, okay? And then B, so B is bonded to H. So you have 2 processes over there. One, you have the breaking of bond between H and A, that is one process. Second, you're gonna make the bond between B and H. So H is gonna be kind of like somewhere in between. So you are breaking the bond with A, And also you are making the bond with a B, so that's the intermediate. Okay, so I'm not drawing two bonds for hydrogen. It's not final product, it's the intermediate. So the bond is breaking, another is forming. So finally one gonna be broken and the other gonna be formed. You're gonna have the carbon. Okay, so you're gonna do something like that. Okay, so here you have that. So this is transition state, and then the C you have the same thing. This is also transition state. D also transition state, right? If you recall Hammond postulate, so which is closer, reactant or the product side? It doesn't say anything, right? So we don't know about any hint on that. So it could be any B, C, or D. Okay? But which is not is we know for sure. So for A, you don't have B over there. So this is not. So this is the answer you have. Right? So you should have both reactant and product. A has only reactant. It doesn't have the product side partially forming the bond, right? So the answer is A. 14. So you have the reaction given, right? So the pKeq value is this. This is for the reaction as a whole. Okay? It says for the reaction is that. And then you have the pKa value for acid. This is given. So which is acid you have in this reaction? Remember, the reaction is specific, right? So for this reaction, which is proton donor? So this is proton donor. So after donating the proton, it's gonna be like this, right? So this is gonna be base over here, proton acceptor, and then it's gonna be like this after it accepts proton. So now which is the conjugate base? So it will be on the right side, right? Conjugate acid, not base. Acid is gonna be this, and then conjugate base is gonna be this. Okay. So now here, what you're gonna focus is 15.6. This value is associated with this acid over here, right? And then the conjugate acid, that's the one you're going to calculate. So pKa is what for this conjugate acid? Right, so remember the formula we had? So the pKeq equals acid minus conjugate base. Sorry, conjugate acid, not base. Right? Or left minus right. Okay, so you're going to use that formula. So I'm going to give you that formula in the exam, but you will not have that in the final. Okay, so that's going to be minus 0.4, and then you're going to have 15.6 plus or minus, right? So minus, let me write pKa of conjugate base acid, right? So now what is going to be the value? pKa going to be minus 16. So yeah, plus 16. Minus 4 going to go to the other side, right? So plus 16. So now you're going to choose which one is that? This one, right? So. All right. So number 15. How many asymmetric carbons you have in the compound below? Or in other words, how many chiral center you have in this molecule? Same thing, right? So you're going to choose the carbon that has all 4 different groups. So you should not have 2 same groups bonded to the carbon, right? So find the carbon that has all 4 different. So obviously you didn't choose that because you have CH3, so 3 hydrogen there. You didn't choose this one, you're going to have 2 hydrogen, right? It has 2 hydrogens there, it's not. This is not. So only center you have is this. So I'm going to write with the star. So that's the chiral center, asymmetric carbon. Why? In one side you have CH3 and then Cl, CH2 and Cl, right? Other you have only Cl. Other you can have 2 carbon and then 3 carbon, right? CH2, CH2, CH3, propyl group on the other side. So you have 1 hydrogen over here. So let me write this way. So you have the carbon that has 4. So you say how many? So you have only 1, right? So that's the one you're going to write. Okay. So now, number 16. Which of the following is chiral? So again, you're going to do the same thing. If you have any molecule that has at least 1 carbon that has 4 different groups attached to that, that molecule is going to be chiral. If you don't have that, it is not chiral. Right? So it is all chiral. Okay? So let me see. What about option C? So why option C is not answer? You have 2 hydrogens on each carbon, right? So you cannot have the same groups. And then D, it may be, I don't know, B, let's say B. So you have CS2OH. Oh no, you have this one, right? CSHO2C is carboxylic COO group like that, or you can draw this way. So CO and then OH. So this is the group, right? So you have this and you have this 2 carboxylic group over there. So that's the same group, right? So this carbon is not chiral since you have 2 carboxylic same groups attached to that, right? And then A, it is a little bit complicated, right? So obviously you have 2 CH3, so this carbon is not chiral. Other carbons are not the N carbons. You have the hydrogen there, 2 hydrogens, right? You have this carbon, and then the other gonna be, what about 1, 2, 3, this carbon. You have chiral carbons there. Why? So if you take this one, it is not symmetric. You have the CO in one part, you don't have that to the other part. So if you cut in half, it doesn't have symmetry, right? It is a symmetric molecule. So this carbon, you have the CS2 over there, you have C and the other groups, you have C and the other groups, you have 1 hydrogen, not shown. So you're going to have 4 different groups over there. Right? So this is chiral. So you're going to choose that. Right? Okay. So 17. Which of the following configuration corresponds to this structure? You have R and S configuration. So which carbon are you going to focus for that? Chiral carbon, always. So for R and S naming, you're going to pick the chiral center, and then you're going to see all 4 different groups attached to that, and then you're going to apply the rules. Remember, you have the rules, right? So you're going to apply that. So first, I'm going to pick the chiral center, this one. So you have the CS3 groups over there, you have chlorine over there, you have C2S5, so this is ethyl group, right? And then you have the propyl group, all this thingy, C3, yes, how many? 8, right? So you have all 4 different groups attached to that carbon, right? So it is chiral. So now you're gonna see the atomic number for the atom bonded to the chiral carbon you have. Okay? So of course you're gonna have carbon, carbon, carbon for the 3. You have the chlorine for the first one. So this is gonna be number 1. This is gonna have the highest priority because it has the highest atomic number. Okay? So now you have the tie in 3 carbon, you're gonna break the tie, right? So you're gonna go to the next atom to that. So for ethyl, you have the carbon next. For methyl, you don't have carbon, you have the hydrogen next, right? So CS3 is gonna have less priority than the ethyl. What about propyl? You have 2 more carbons after that. So this is gonna be number 2 you have, this is gonna be number 3 you have, this is gonna be number 4. So you label the number based on the atomic number. Okay? So what is the next step after that? You're gonna flip the molecule. It doesn't mean that you're gonna break the bond. You are not breaking the bond, right? So you have the molecule. So you are not breaking or replacing any bond in the molecule. So you are just like a flipping here and there for the whole molecule, so that the least atomic number you have there, which is number 4. So that number 4 is going to be a back from your side. Okay? So here it is already back. So the dotted line is on the back, right? So if it is on the front, say for example like this, what are you going to do? You're going to flip that, make it back. Then you're going to see the order. Clockwise or counterclockwise. Okay? Yep. Mm-hmm.
Why did you know it was a methyl and not a hydrogen for the hatches?
Given number 4? Because it is given. So it is dotted line over here, right? That means on the back. So say if you have, let me draw this way. So let's say you have Cl, and then let's say you have CS3 over here, and then like that. So if you have that, what do? You're gonna flip first. Okay?
Right.
Then,
I'm sorry. I was wondering how you knew that was a methyl though.
oh, because you have C, just one line in there.
And not a hydrogen.
What is that? If you have one line, so what is going to be the formula for that? Remember the line angle drawing formula? So whenever you have end, that's going to be carbon. So end is going to be carbon. So you have CS3, you have CS3. So carbon should have 4 bonds, right? So you have the one bond with the carbon over here. So you have 3 other bonds there. So should be hydrogen 3. So in the same example, so your question is, let me draw over here. No, this is not complicated. So I think you're like being a complicated one, easy one. So you have this, right?
Yeah, and I wanted to put an H there when I did that.
No. So this is like a line. Remember? So what you are doing is, so let's say this is chlorine, right? So if you put this way, you're going to write the bold face for this mark. If you do this, you're going to write the dotted line for that, but still the bond you have. So you have the carbon. So for example, if you have like this only bond, what do you write over here? Carbon. Again you get confused. So I'm going to write this CH3, CH3. Okay? So what is the, okay, so let me write CH2 and CH3. So what is the line angle formula for this molecule, propane? Right? So why you write that? This end is for this carbon. This is for this carbon. This is for this carbon. Same thing. Right? So, all right. So now what is going to be the name? So you're going to see 1, 2, 3. 1, you're going to go 2, you're going to go 3. R or S?
Yes.
All right. So that's going to be the answer. Okay. So let me speed up a little bit. So enantiomers. So how do you define that? So enantiomers are like this, right? So you have one molecule. You're going to put the mirror over there. You're going to have the image of that, right? So this is enantiomers of this. This is enantiomer of this. This is the pair. Enantiomer pair. Okay? So you're going to do that. So here, a chiral molecule. So you must have chiral to have the mirror image that is not superimposable, right? So you must have chiral that is non-superimposable mirror image. That's the definition. Or chiral, you don't do that. So enantiomer is formed from the chiral carbon. Okay? And then any pair of molecules that are superimposable, no, should be non-superimposable, not superimposable. Okay? So C is not, D is not, A is going to be your answer. Okay? So 19. Draw the structure of enantiomer of the molecule shown. So this is the molecule given. So what you're going to do is you're going to find the image of the molecule that is not superimposable on the molecule itself. Okay, so what's going to be? What is the easy way to do that? You're going to focus on the chiral center. Okay, so don't focus on that. Don't focus over here. Don't focus over here. Not over here. Not over here. These are non-chiral centers. Okay, so your chiral center is going to be this one, because you have the hydrogen on the back for that, because bromine is on the front already. Okay? And the second one, you're going to have the hydrogen on the back, because you have the CH3 on the front already. So you have two chiral centers in this molecule. Right? So now, when you make the image, what are you going to have? So you're going to make the bold phase of one group to the dotted phase. So it's going to be the enantiomer, right? So you have bromine, so bromine at the back. CH3 front, CH3 back. Right? So you have only change in the position of group at the chiral center. Everything else is going to be as is, without any change, right? So this is the enantiomer. Okay, so B is not, because you have the bromine and CH3, the bromine, so you have extra Cl here, you don't have that. It's not molecule, right? B is not molecule. And then C, you have the RCl over there, that's not the same molecule. D, it's not the cyclic molecule, right? So obviously it's going to be A. Okay? All right. So which of the following is true for the compound R2-butanol? So you have 1, 2, 3, 4, 2, you have OH. So butanol, you have the hydrogen over here. So this is the chiral center you have, right? So R means it's going to go clockwise, right? So the way I draw over here is number 1 for oxygen, number 2 for that, number 3 for another carbon, number 4 for hydrogen. So then I write dotted line for hydrogen, it is in the back, right? So this is going to be the R configuration. So R2-butanol. Okay. So now see the options. So what it asks? This compound is chiral. Yes, you have the chiral center there. That's true. This compound is optically active. Yes, you're going to rotate the plane of polarized light. So this is true. And then this compound has enantiomer. Yes, you're going to put a mirror, you're going to have the image that will not be superimposable if you try to coincide the chiral center together. Okay, so this is true. All of the above, yes, A, B, C, all right. So that's going to be the answer, right? So 21. So predict the specific rotation of the compound. So this molecule, do you think gonna have the optical property? No, it does not have the chiral center. So all carbon you have in this molecule is all chiral center. So it is impossible to predict. It must be determined experimentally now, right? And the other gonna be both asymmetric centers, so you don't have any asymmetric center over there, right? And then both center are S, no, that's not. 0, the compound is achiral. That is true. It is achiral molecule. And dextrorotatory, it doesn't rotate light, doesn't say right or left, right? Doesn't do it. So this is not. So D is gonna be answer. So this is achiral molecule. Right? You must have the chiral center to have the optical property. Okay. So 22, how many diastereomers are there for the molecule shown below? So how many? So for that, you're going to count how many chiral center you have there. That's the first thing. Once you count, you're going to use 2 to the power n formula for that. So you're going to find out n first. So what's going to be the n in this molecule? N is chiral center, right? So this is the only center you have. All other carbons, you have 2 hydrogens, right? Or double bond. These are not chiral center. So you have 1 chiral center. So 2 to the power 1 is going to be 2. So your answer is going to be 2. Okay. Alright, 23. The stereoisomers, which are not mirror image isomers, are called diastereomer, right? So, which are going to be enantiomer, right? So, which are also you're going to say the non-superimposable over there and that. But as is without doing any modification, this is going to be diastereomer. Okay. And the meso compound is going to be, you're going to have the plane of symmetry in the molecule. One part, you're going to rotate the light in one direction, other part in the another direction. So you can have the overall cancellation of the rotation. If you have that molecule, that is meso molecule, right? So cis trans doesn't come in the optical property, right? So identify the atom economy for the molecule. So for this one, you simply apply the formula. I'm going to give you the formula in the test, but remember, in the final you will not have. Okay? So simply put the value. So take the molecular mass of that, count the molecular mass of that, and then count for the product, and then you're going to use the formula, right? So product over reactant times 100, so you're going to have the answer. Okay? So this is going to be about this. Right? So sometimes, if you want to simplify quickly, just see the change in the number of atoms you have. If you have the same number of atoms here and there, so you're going to have the same mass on the top, same mass on the bottom, you're going to be cancelled out, so 100%, right? So this is over here. So you have this unit, you have this molecule, you don't have any byproduct there, you have only one product from the reactant. So this is the efficient reaction, right? So you're going to have 100%. You have the same mass for the product, for the same mass for the reactant. So, okay. Yeah, you can just guess without doing the calculation. And then 25, which of the following represents the green matrix? So green matrix are the 12 points you have in the slides, right? So you have 12 matrix. So what are they? So E factor, it is part of the one metric, right? And then the effective mass yield, also part of the one of those 12 points you have. Process mass intensity, PMI, this is also part. All ABC, yes, you have all three there. So you're going to choose the D. Okay. All right, so we have 3-4 minutes, right? So now you can ask any question I can answer. So all clear? So you're going to do good in the exam? Right? So let me highlight a few of the things. So most of the time you're going to have confusion, right? Say for example, I'm gonna say you one. So don't memorize the answer directly, okay? Let's say this diagram. So here it is asked, which are the lower EA and higher EA, right? If I ask the same question, which one is the faster reaction, which one is slower reaction, then which one do you take?
Faster would be
The conversion.
So-
the lowest. Or I'm sorry, the highest.
Other way, yes.
The highest. And then the fastest.
So you have two reactions over here, right? X to Y, Y to Z. Two steps there. So X to Y can have the lower EA as given over here. Y to Z can have the higher EA. So now I can say the same thing in different ways. I can say which is the slower step or reaction, or I can say which is the rate determining step for the reaction, something like that. It's going to be the same thing. Right? So if I say which is the slower reaction, which one do you pick? X, Y, or Y, Z? Okay, YG is going to be slower because you have the larger barrier to cross. It's going to be harder. Okay? And then which one is going to be the rate determining step?
YZ.
YG, right? So the larger the EA value you have, slower going to be the reaction. They're going to control the speed of overall reaction you have. Right? Something like that. So just think the question in different direction, like ask why this is the answer. If you do that, you're gonna do good. Next time.